converting a binary number to decimal. This conversion is just a little bit harder than the other two you've learned so far because we have to do a little bit of addition to get the answer to this. First of all, we need a binary number. Once again, once you're given your binary number, use your binary row up here to put that number in. So the number we're going to work with is 1, 1, 0, 1, 1, 0, 0, 1. All right, notice in this chart here that we have a row called value. And this value row here tells you what each place in the binary number, what it means, or what its value is. This is the 1's place, the 2's place, the 4's place, the 8's place, 16ths, 32, 64, and 128. And this can continue on to infinity as well. This is the same thing you learned in grade school working with the decimal number system that you've been working with your entire life. You were told in grade school that the first number was the 1's place, the second number was the 10's place, the third number was the 100's place, the fourth number the 1000's place, the fifth number was the 10,000's place, and the 100,000's place, and so on and so forth. Well, down here we represent binary in base 2. What that means is we only have 2 numbers in the numbering system, so that's known as base 2. Well, in grade school you've learned that your numbering system has 10 numbers to it, 0 through 9. So they called that base 10. And if we were to go down here and say 10 to the 0, well, 10 to the 0, there's your 1's place. 10 to the 1, well, that's 10, there's your 10's place. 10 to the 2, well, 10 to the 2 is 100, there's your 100's place. 10 to the 3 equals 1,000, so there's your 1,000's place. All we're doing is representing a base 2 number by using the number 2 instead of the number 10. And that gives us the value for each of the placeholders here. Now what you do is you take your binary number, and anywhere there's a 1 in the binary number, you add the values of those 1's. Let me show you what I mean there. We have a 1 in the 128's place, so we put 128 down here. We have a 1 in the 64th place, so we put 64 here. We have a 1 in the 16th place, so we put 16 here. We have a 1 in the 8's place, so we put an 8 down here. And we have a 1 in the 1's place, so we put a 1 here. And then we simply add all of these numbers together. 128 plus 64 plus 16 plus 8 plus 1 equals 217. So our decimal number for the binary number 11011001 is 217. And the chart is showing you this. That's what this add here means. You add the values of wherever a 1 appears, and you'll get the decimal number that's associated with it. Let's go ahead and do another one. This time we'll use a binary number that starts with a few zeros to show you it's the same thing. This time let's use the binary number 0, 0, 1, 0, 0, 0, 1, 1. Same thing, same method. We look in our row here and we see where the 1's are. Well, the first one we have is a 1 in the 32's place. So we put 32 down here. We have a 1 in the 2's place. So we put a 2 here. And we have a 1 in the 1's place. And we put a 1. We add all those together. 32 plus 2 is 34 plus 1 is 35. So the decimal number that represents 00100011 is 35.